When you take wire and wrap it around a tube, like has been done here, you get what is called a solenoid, or a coil of wire. If you put a current through that wire, as many of you did in the 3rd grade, attach the two ends of this wire to a battery, then you can produce a magnetic field down the axis of the solenoid. And that produces, and that is what is known as an inductor. Here are some examples of inductors. They're just coils of wire. Here's one with maybe 10 or so windings in the coil, 1, 2, 3, etc. This one has many more. This one has a very large number of windings. You'll find inductors in circuits. This one is a rather large one with very, very small, fine wires in here. And so anytime you see a little coil of wire in your computer or in another circuit, we're talking about an inductor there. To demonstrate the magnetic field produced by a solenoid, I've energized this coil of wire with this power supply, and I've got this magnet. It has it's just a compass, actually, and all a compass is a bar magnet that's has an axis of rotation. So you should be able to see a red end of the bar here and a blue end. The red end indicates the north pole of the magnet. So if we bring this in the vicinity of this coil, you can see that the north pole is pointing into the coil of wire. And as we bring this magnet around, at this symmetric point on the top, I'm going to up the current a little bit, the magnetic field is now pointing this way. Down here, the magnetic field is pointing this way into the interior of the coil. Out here, the magnetic field is pointing this way. And then, so slowly bringing it around, you can see now that the magnetic field is again pointing this way. It's the direction of the red end of this bar magnet. So the important thing here is that the magnetic field points axially through the coil of wire. And I can actually, you won't be able to see it in the camera, but I can pass this all the way through and show that the magnetic field, especially in the interior, you might be able to see on the camera that, well, it was vibrating a little bit. I guess it's not going to do that anymore. But the bottom line is that the magnetic field is very strong in the interior of the solenoid, and I can feel its strength with my fingers here, and weaker on the outside. In the limit of a very long solenoid, that you extend windings all the way out to infinity that way, and all the way out to infinity this way, the magnetic field outside of the solenoid is actually 0. And inside the solenoid, it's very strong. And you can calculate that magnetic field inside the interior of the solenoid. So that's inductors and solenoids.